Hello, I'm Robbie Mochrie, and today I'm going to talk about part 2 of my textbook Intermediate Microeconomics, which looks at how people make consumption choices. All that I'm going to talk about is how to construct one fairly simple diagram. It might seem very simple to you, but it captures some very important economic principles. Indeed, I'll go as far as saying that if you understand all of the ideas that are captured in it, then you will be well on the way to understanding how economists model the process of making choices. Let me start off by explaining what it is that we're measuring. You'll see that I've called this diagram consumption bundles. Every point in the diagram represents a different consumption bundle. I've labelled the axes loaves of bread and kilograms of cheese. So we're measuring the quantity of bread in the consumption bundle on the horizontal axis and the quantity of cheese on the vertical axis. And I've drawn the point Z in the diagram so that it represents the consumption bundle consisting of 10 loaves of bread and 4 kilograms of cheese. I've shown it in two ways in the diagram. Physically, Z is 10 units to the right of the origin, which is where the axes cross, and it's also 4 units above the origin. But I've also shown Z simply as the ordered list, as Z 10, 4. Now, you might ask why I've chosen that second way of making the point. Think of it this way. The surface is two-dimensional. I can move to the right and I can move to the left. So I can show every consumption bundle with an amount of only 2 goods in the diagram. And here's some good news. 2 dimensions are just enough to make the arguments that we will develop in this course and to show all of our important results in diagrams. But there's even better news. We're not restricted to thinking only in terms of 2 goods. We can have consumption bundles with quantities of 3 or 4 or 43 goods or really any number of goods. But to do that, we need to use some quite standard mathematical techniques. Now, when using mathematical tools, it's good to think in rather more general terms. So that means that rather than thinking of specific goods, we just think in terms of 2 different goods, B and C. And instead of thinking of quantities of each good, we're going to think in terms of a general consumption bundle, Z, which consists of some quantity of both good B and good C. As we're developing our model of choice, we're going to need to understand 2 properties of every consumption bundle. The first one we're showing here is whether or not the person making the choice can afford to purchase it. The second one, which we'll discuss later, is whether this person would prefer a different consumption bundle within the affordable set. And what we're really wanting to do is to be able to answer the first question, yes, so that the consumption bundle is affordable, and the second question, no. There's no better consumption bundle within the affordable set. What we'll then find is what we call the most preferred affordable consumption bundle. How we find that consumption bundle is absolutely central to the argument of this part of the book. Now, in the diagram, I've drawn this light green triangular area, the affordable set. That consists of all of the consumption bundles that the person making the choice can afford. Very often, we're really interested in what is going on at the edge of the affordable set. I've therefore shown its boundary as the heavy downward sloping line, the affordability constraint, but you may have met it before under its other name, the budget constraint. This constraint is a line if the amount of money available to the consumer is fixed, if there's a fixed budget, and the prices of the goods are also fixed. If we make those particular assumptions, then the constraint is where the money runs out. The cost of acquiring every bundle in the constraint is just the amount of money that is available to finance consumption. And you will see, of course, that I've placed bundle Z on the affordability constraint. That means that Z is just affordable. I said there were 2 questions that we wanted to ask about consumption bundles such as Z. The first was whether it was affordable, and the answer to that question has turned out to be yes. The second question was whether there is any affordable consumption bundle which is preferred to Z. This is a rather different question from the first one. We imagine that it's possible to compare every possible consumption bundle with Z, and for the person making that choice to say whether Z is preferable to the alternative or else whether the alternative bundle is preferable to Z. I've assumed that the shaded area, labelled preferred to Z in the diagram, shows all of the alternative consumption bundles that are preferred to bundle Z. Now, about the only time that I go through a process like this is when I'm getting my eyes tested, and the optician gives me a series of binary choices. Is the line closer to the centre of the dot in bundle 1 or in bundle 2? And as we do the test repeatedly and the lines get closer and closer to the centre, I might ask to see them both again, but eventually I will decide that the line is closer in setting 1, or else the line is closer in setting 2, or else that the lines are equally close to the centre of the circle. In the same way, someone comparing consumption bundle Z with an alternative may eventually be unable to say that one is preferable to the other. Where we have a pair of bundles like this, we say that the person is indifferent between them. In the diagram, I have shown all of the consumption bundles that this person making the choice considers to be just as good as Z. It lies on the boundary of the preferred set, and I've called this boundary of the preferred set an indifference curve. It might seem an obvious point, but we expect to see Z lying on its own indifference curve. Suppose that you compare one consumption bundle with another consumption bundle that's actually exactly the same. How would it make sense for you to say that you prefer one to the other? Now we can think about why bundle Z is the most preferred affordable consumption bundle. Consumption bundle Z lies on the affordability constraint and on the indifference curve through Z. Affordable bundles lie below the constraint line, but the bundles preferred to Z lie above the curve. That means that there are no affordable bundles in the preferred set apart from Z. In fact, Z is the only affordable bundle that even lies on the indifference curve through Z. And what that means is there is no affordable consumption bundle preferred to Z, so that Z is the most preferred affordable consumption bundle. At this point, there's just one more thing that I need to say. At point Z, the affordability constraint and the indifference curve just touch, but without crossing. We say that the affordability constraint is tangent to the indifference curve, and so Z is the point of tangency between them. The geometric relationship between an affordability constraint and an indifference curve at any most preferred affordable consumption bundle will usually be this tangency. Throughout this part of the book, we're therefore going to be looking for ways of setting up problems so that we can work out where these points of tangency, like Z, will be on the diagram. It would be nice, of course, if we could simply rely on diagrammatic techniques, if we were simply able to rely on diagrams as proving our argument, rather than simply being illustrations of it. So from here on, we're going to need to start using mathematics to represent the affordability constraint and the indifference curve through any consumption bundle. And we'll also then need to develop a mathematical test to identify the consumption bundle where the affordability constraint just touches the indifference curve.